So what did we cover just now? Duckweed, yeah. It's easy to cultivate, yeah. There's no rocket science that you don't have to get special species and other things to do it, yeah. Now we'll go on to the production of macro and micro algae, yeah. And how many of you have seen algae? You all, yeah. Which one, micro or macro? Now, first question itself is, so far whatever we were talking about, all the blue economy, blue circular economy and blue bioresources, do you think is sea a sustainable solution? So far whatever we have covered, almost 9 lectures, you would have seen oceans are going to be the one going to solve all the problems, yeah. But in theory, based on the history, it is because all the life originated from water, yeah. That's the reality. So the two important things when it comes for sea is the focus on biomass and how we maintain the biodiversity. That two things are very, very important. If we are doing overfishing, yeah, then we are eliminating certain nutrient from the seawater. So that's why the balance between these two becomes very, very critical, yeah. So that's the reason why we have to have a proper balance. Either you go with aquaculture or a wild harvest. So when we do commercial harvesting of seaweeds, yeah, we already covered what is wild harvest and aquaculture. Those who are new, you can look into the previous one. I don't know, it should be available online to see what is difference between wild harvest and aquaculture. So the problem with this wild harvesting is, what are the waste produced from commercial seaweed harvesting, yeah, which is grown naturally. If you remove all those wild harvested seaweed, then there is a problem of again silting, and these seaweeds, they bind the shores, otherwise lot of sand and everything will be migrating. You know all those issues of silting of rivers, removing of the sand from river bank causes flood and other things. There all purpose is there, naturally all those things builds up, yeah, and also prevents from storm. That means it protects us from storm and other one, right? So that's why it's very, very important when you do harvesting. It includes lot of different types of licensing. Now this is actually from County Kerry, yeah. It's very, the whole of Irish population is around 5.8 million, yeah. Out of that, 75% of population lives in 3 cities, yeah. So all this area, if you'll see, this is the sea, and this is all seaweed which is there on different rocks, yeah. People, they go in and they harvest. This man's name is Henry J. Lyons. He was a professor and dean in a university, and he started 4 or 5 different companies of seaweeds. And then it's a big business at the moment. He likes all this. So by looking at the seaweed, he can identify what type of seaweed it is, yeah. To some extent I can, yeah. Like if you see the rice, oh, this is a basmati rice, this is not a basmati rice, this is Dehradun basmati, this is pony rice, you know. Farmers, they know it. You ask scientists, they say, oh, I need to test this aroma, that profile and all, yeah. So there is a difference. All those guys who are from dairy, what is the difference between cow and a buffalo? Don't tell me the color, don't tell me about the milk, yeah. If you see an animal, how do you know this is a cow, this is a buffalo? There is only one difference between cow and buffalo. What is that? Physically. Anyway, cow contains collar, buffalo doesn't have a collar. Yeah, right? Horn is there, color is black, yeah. I know skin wise and all you can identify, but physically there is only one difference. But you say the milk is thicker compared to this, cow milk is yellowish color, right? Same way, some of the identification of the seaweed is also there. Like I mentioned some of the species previously, that is Escophyllum nodosum, yeah. This name came in because it contains node, fucus vesiculosus, yeah. And there are different types of names are given. Broader classification: green seaweed, brown seaweed, red seaweed, based on their natural color, A. Another classification is given based on what is their structure like, bladderwrack, yeah. And then other ones are alaria. So there are number of different species depending upon the geographical location they grow. And broadly they are also classified as kelp. Sugar kelp, Saccharina latacema, yeah. So that's sugar kelp. So kelp, seaweed, macroalgae, all these are the different names of the same biomass, yeah, right. So that's and these are mainly grown at underwater dense forests. You would have seen the video other day. So they start from the bottom. They can be as long as 2 meters and 3 meters, big long fronds. Fronds means like how it is there, and it is attached to a surface with hold fast. It is very difficult for you to remove that seaweed from the rock. They attach very nicely, like a snails. If they are attached to the rock, you can't remove it just like a normal hand. It is having very good adhesive power, coupled with the compound it contains plus the vacuum it creates, yeah. So that's what builds with dynamics of ecosystems on earth. So wild harvest, which grows and is just cultivated directly, that is harvested manually or by mechanical manner, and this is completely mechanized way of harvesting. So I'll go through this small bit with the production and then how we process it. Now, what is really an economic value of seaweed? Because this has been quite important. One, it can address the issues with protein deficit, food shortage, population is growing, and the climate change. So we need to produce crops which are carbon neutral or carbon negative. Anything we produce that is having an impact on a climate, whether it's rice, wheat, any other crop what we grow, they have impact on environment, because we need a land, we need a fertilizer, we need a resources. Whereas seaweed does not need that sort of input, because you just throw it into the sea, it grows on its own, yeah. So as you can see, these are again the statistics, how the wild harvest remains stagnant and aquaculture production is increasing. So we discussed about aquaculture as IMTA system, yeah, integrated multi-tropic aquaculture. That means you grow seaweed, you grow shells, you grow different fish all together, yeah. Whereas you can only grow seaweed also, and it solves lot of aspects related to United Nations Sustainability Developmental Goals. And as you can see, among number of countries, how much aquaculture is there in near about Asian subcontinent. China is number 1 in producing seaweed. Indonesia, Philippines, Korea, Japan, Korea. Where is India? We don't have much. It's still there, but not huge. So there is a huge potential again. We have long coastline and to produce aquaculture seaweed. Yeah, may not be for food purpose, for other application, alginates, carrageenan, all those biomasses or those ingredients can be obtained from seaweed. At the moment they are extracted, they are produced. There are a couple of institutes here like in Kerala as well as in Gujarat, which deals with seaweed aquaculture as well. So if you'll see the economic importance, how much seaweed is produced and harvested, yeah. So first one is the key ingredients what you can get out of it. Carrageenan, agar-agar, alginate. You know about agar-agar, which is used extensively as a microbiological media, but that is also used for food purposes. All those jellies, sugar jellies, they all contain this type of stuff. Same thing, alginate is also used for encapsulation of yeast for fermentation. That's sodium alginate is soluble in water, calcium alginate is not soluble in water. Food supplementation, minerals and dietary fiber, yeah. How many of you have done experiment with alginates, creating alginate beads, yeah?
Sir, in our laboratory, in plant tissue culture, we make a synthetic seed with the covering of sodium alginate.
Okay. Have you seen a brand on edible water? A lot of things were there with edible water. If you make 1% sodium alginate solution, a lot of applications are there for alginates, even for agar-agar, carrageenan in hand creams and everything. 1% sodium alginate solution, if you dip this water, you add anything to it. You make 1% alginate solution even in orange juice, apple juice or whatever juice you want to make, you make it. Then you also make 1% or 2% of CaCl2 solution, yeah, and this was formed in shells, yeah. The moment you drop sodium alginate beads into calcium chloride solution, it will form a bead, because calcium alginate is not soluble in water, whereas sodium alginate is, yeah. So now you can make those vacuoles having a liquid inside and it's fully encapsulated biomass, yeah. So you can make edible water, because 1%, that means rest is water, yeah. That's how it can be used for encapsulation. Add 1%, and if you want to do experiment, we can arrange here, you can see it, yeah. Then you introduce your juice or whatever you want to introduce it, you do it, and then the moment it goes into calcium chloride, you'll see small bead formation. Same type what you see in the market, if you just go on internet, you will see the edible water. That same water balls are made with sodium alginate dipped into calcium chloride, and outer one becomes calcium alginate, and in the center is all water, yeah, and it cannot be broken just like that. So you can just swallow it, and alginate is consumed as a food ingredient, yeah. Protein and all those things, fertilizer, plastics, again, because agar-agar, carrageenan, alginate can also be used for making biopolymers, alternative to plastics. Because carrageenan is extracted, you take a seaweed, boil it at 90 degree or 100 degree for 3 to 4 hours. Whatever is extracted in a water, you cool it down, it forms a gel, yeah. So that's basically a carrageenan extraction process. If you remove a carrageenan, leftover biomass will be fiber and a protein. Then you use your enzyme to break the fibers, you get your sugars, then you have your protein. You will see all those things coming in next few slides. So major producers: China, Indonesia, Philippines and Korea, yeah. Then environmental benefit. It captures the CO2 and inorganic waste. That means any of the carbon polymer formed in a seaweed, where carbon dioxide comes from, environment. We have CO2 as a major greenhouse gas, yeah. If 1 kg of seaweed is produced, yeah, and it contains 60% as carbon, yeah, that means amount of CO2 it has already absorbed from the environment and produced carbon biomass, yeah. Then you have your much more yield compared to land. There is plenty of sea, you are not disturbing anything. Then you don't need a fresh water to grow this biomass, yeah. So there is an error here, growth of this biomass, yeah. Then ecosystems, coastal ecosystem services. You have seaweed cultivation, it will and also save your erosion, that is again you are going into this, and carbon sequestering. Carbon sequestering, carbon offset, carbon tax, carbon miles, you would have heard all these words, yeah. Carbon sequestering is absorbing atmospheric CO2 and converting into some form of biomass, yeah. Now, I did ask this question before, or I did discuss previously. If suppose there are 2 trees, yeah, or 2 plants, plant A and plant B, which one will absorb more CO2? How do we establish that?
It's depend on how much, just like glucose is produced, biomass is produced, which species, like species 1 or species 2.
True. So you know the photosynthesis process,
Yes.
right? Yeah.
Carbon dioxide plus water is
6 CO2 plus 6
6
H2O
It will be converted into glucose.
C6H12O6 plus
Plus
oxygen, right? So if you measure amount of 6 molecules, or just do all the calculations, 6 into 12, yeah? CO2 molecular weight is what? Carbon is 12. Oxygen 16. 16 plus 16, 32. Sorry. 32. 44. 44 units of carbon, yeah, into 6 times of this will produce this much amount of carbon in the form of glucose, yeah. So if you measure the biomass of that particular plant or a tree or a species growth over time, yeah, that will show how much carbon dioxide it will need from the environment, yeah. So that is the way you can calculate the carbon sequestering potential of any crop, yeah. Easier answer is I will look into literature, yeah. But every crop, every plant on this earth is not available on literature, yeah. But the basic way is measure the carbon, nitrogen, oxygen, sulfur content of that biomass by using elemental analysis, and then all these things are coming from nitrate, nitrites, carbon dioxide and all those fertilizer. That way you can measure how much it will quench, yeah, right? Simple. So all these methods are simple. So you don't need LCMS, MS to do all those measurements, yeah. This is simple calculation, basic chemistry. So if you'll see this, this is the European scenario. It's only building now to produce aquaculture. There are a lot of policies are there, a lot of blue economy things are going on. This is Iceland, this is Ireland, Portugal, Spain, France, all these coastal countries are going ahead with cultivation of micro and macro. You can see both macroalgae and microalgae. There are some landlocked countries, they are trying to produce seaweed on land either by using fresh water or by using seawater, some form or the other, yeah. So this is all the statistics. 13 species are used out of 600 native species. There are more than several species are there. Some are invasive species which are coming through the water because water bodies are attached to each other, yeah. And license, that means 180 hectare of land has been having a license, and getting a license is quite complicated because sea is not only used for production of seaweeds, but also for other aquaculture purposes, recreational activities, kayaking, scuba diving and all those things. So licenses has to be applied. It's not that you just go and start using sea to do production, yeah. And I have no idea about licensing system and rules related to use of coastal water, yeah. Farmers, fishermen, they don't need a license. I think they do need a license about within the border. They can go and do the fishing, yeah. There's no area belongs to an individual farmer. But somebody want to use that one to produce seaweed or aquaculture, they may need a license or they may need a permission to do so. It's very simple. If you want to open a physical shop, you need to have a shop license or you need to buy a shop. Whereas if you have a trolley system, you don't need that, yeah. That's why we call it grey economy and unorganized economy or organized sector, yeah. So that's one. Now when it comes to current production, and I did made a reference of BMRS, that's a company in Cork, that is Bantry Marine Research Station. And if you want to see all the projects, and they are the one which work with us on all the bioprocessing side of it, biorefinery production and other elements, yeah. So if you have any questions, you can go onto the website, you can see the email. If you want to ask information, you can, yeah. So Bantry Marine Research Station, land-based cultivation and sea-based cultivation, the both are there for macroalgae. Here you have aquaculture, and if you'll see, this is the sea and this is the way harvesting is done by boat. Majority of the harvesting is manual and rest is mechanical. How it is grown, we will see in next couple of slides. These are all images and you can find that, right. So, as I mentioned about Bantry Bay, that is Bantry is south of Ireland and Cork, and they have 16 hectare of sea site for licensing or licensed site to grow aquacultured seaweed. Yeah. Any idea in 1 hectare how much of biomass can be produced? Several tons. We will see that. So, seaweed hatchery, that means all these strains, they are grown first in a lab. Yeah, all those spores and culture you will see that live, and then once it is done, it is roped around a single string of rope. That you can see, this is the life cycle of it. This is the full grown seaweed, similar to mushroom, the sporophyte, sporophylls, and these spores are attached to a single thread, and that particular thread is tied on to the rope. You have seen that video the other day when we were running. Yeah, it's tied onto the rope and is thrown into the sea. Yeah, I think if you remember vaguely the video what I was playing. So, if you'll see sorting in the lab, and these are what are collected from seaweed. This is a particular seaweed which is grown wild, and from there you collect the spores, put it on to the string to create sporophyte, and what you see here, this is basically a rope. Here is a very thin rope. Yeah, this is very thin rope which is tied together. This is dipped into spores so that all the spores are attached to that particular rope. That rope is very thin, you will see in a minute. And that particular rope, can you see this? This is lines are simple ropes, and these ropes are tied onto a thicker rope. Yeah, that means you have big thick string, powerful string made up of jute or so, and then this thin string is tied onto that rope. Yeah, like a thread. This is your rope, and you just tie up with the thread, and the whole of that thread bottle was dipped into the spores. Yeah, that means something like a microbial contamination, and then this rope is thrown into the seawater. Yeah, and these balls, what you will see, are so that they are only floating. Yeah, they do not go down. That's the reason these are balls in something like this 1.5 meter, and this is the string which is connected to this water balls, which is floating, and the string is there in the water. That is it. Yeah, spores onto thin string, that string attached to a bigger rope and dipped into the sea. Deploying seeding string onto long lines at sea. So, if you will see here, these are the thin ropes, what you can see. Okay, that is clear enough. Yeah, because this one is much clearer than that one. Yeah. So, all the strings on this, and this particular one is dipped into the solution to get all the spores, depending on the species you want to grow, then tied onto this particular rope, and this rope connected to these type of water balls. You have seen that those balls are there in if you go in water sports, especially in near Marina Beach and all those type of how many of you gone what's called water sports place in Chennai, ECR Road, water boats and all, you have gone there just to mark it, not to go beyond that. So, those are floating balls thrown in the water and attached with the string so that it does not move, and this could be hectares and long, could be a 100-meter long string or could be 200-meter long string. Yeah, this one is 110-meter long string and attached to a concrete block. Yeah, otherwise because of flow of water it will move to different places. Yeah, it's something like you have a rope to be hanged in a water. Yeah, this is for floating purposes, and this is for having the rope at a specific point. This is what is done in boats, and then after 4 to 6 weeks this happens, and these are real picture from the production site, picture taken on 13th of January, and this is another one 1.7 meter 8th of January and 23rd of January. This was done to see the seasonal variation, year to year variation, and this is what happens, and this is what it grows like. Yeah. So one single spore can create such a long seaweed, and final harvest is after 5 months. That means in February, and normally it is done in November and December. These ropes are thrown into the water, you forget it, and after 5 months you collect that rope and remove the seaweed. Yeah, simple. So which one look more interesting, duckweed or seaweed? Yeah. So that's, and then land-based free floating, that one what you saw was Saccharina latacema, from where what we get? We get alginates. Alaria esculenta also you have alginate and used directly for consumption. All species are not 2 meter, 3 meter long. Some are the smaller species like vulva, the green ones, Palmaria palmata, Porphyra, Codium, Chondrus crispus, for Carrageenan, Glarcia. See, I know all these names now just because keep seeing it and keep talking about it. It's something like Saccharina latacema. So that is grown in Norway, and all these alginate production, commercial alginate productions are done from those. Now, vulva, it contains high amount of protein, 29% is good. Palmaria palmata, and all these seaweeds, and some, as you can see, different aquaculture farms. Yeah. If you go and put aquaculture seaweed production, you will see plenty of different design. Whenever you get a time, you can go to China and you can see how the seaweed is cultivated, how it is dried, and the same rope, because in Ireland is a cold country, you can't get it dried in sun. The same rope is hanged near the sea, it dries. You collect it, mill it, you have milled seaweed. Yeah. But if you have to use microwave drying or any other hot air drying system, it adds energy. So seaweed production cost increases. Yeah. So that's the way it can be cultivated, either creating an artificial water bodies, or this is at sea, or on land. Yeah. Does it make sense? So if you have large protein production plant to produce a plant protein, leftover solution will be a salt water. Yeah. Can we use that salt water to grow? I'm not good at using the pen. To grow seaweed, or that salt water to grow duckweed, or to grow microalgae, or any other species to produce biomass of biological origin. So we are not competing with the land, and we are trying to get something cultivated without using any other resources. Yeah. So this is all your land cultivation. Now coming back to IMTA system. Yeah. You had a clear video and photograph in the previous lecture. Now this details you can find it again. This is a bigger project. This is a Portuguese company, Alga Plus, who produces this biomass, and they are making a lot of vegan fish type product, vegan product, and using it in different product formulation. So this is again the street names, so forget about these street names. So then you have reservoir, you have fish, sedimentation, and this is the way it looks like, how it is calculated. Sea bream and sea bass is a species of a fish, and it also requires whatever feed, and that seaweed or microalgae what is cultivated can be used for making fish feed. So what you are seeing here is how we can use different IMTA system only for seaweed. And again, there is also an organic production of seaweed because we are not adding any input, and there is an organic certification. So now market is shifting more towards organic ingredient, and if you have cleaner process to obtain carrageenan or alginate, so you have organic alginate which is not there at the market, and soon you will see some of the products coming in the market. Yeah. So in that case, you have to have an extraction process which does not include any of the chemical for extraction. Yeah. Organic potato is there, but organic starch is not there because you use a chemical. But if you get a starch without using a chemical, you have organic starch, so you are creating a niche market for getting a premium price for that particular stuff. Now, that was the rosy part. Alaria esculenta looks like this. This could be up to 1 to 2 meters long. Yeah. Laminaria digitata, laminaria, a lot of different species of laminarian is there. Saccharina latacema, it's known as sugar kelp. These are all abbreviation of the countries where these are cultivated. Yeah. Now, I'll quickly go through all the legislative issues. 1. Common fisheries policy. Alien species. That means you cannot take any species from one country and put it into other water. Yeah. You would have seen in agriculture, lot of biomass we have in a country, weeds which are not origin to India. They just came in with the people, either they imported it or it came by chance. Yeah. One is I think Cynodon dactylon, that is also not native to this place, I believe. Yeah. Certain seaweeds are Parthenium, I think. Yes, Pythenium is the one which is not of native and it just came in by chance or by some seed or crop. So this is what it known as alien species regulation, common fisheries policy. That means setting out rules for management of fishing fleet which ensures conservation of fish stock. That means whatever fishing you are doing, you have to keep the stock on land. You cannot dump it back to the sea. Yeah. That means if you harvested the fish, certain amount of fish you don't want because they are dead or whatever, you cannot throw back to the sea. That was the one of the reason common fisheries policy was adopted. That's we call it as bycatches. Yeah. Yeah. Alien species. Again, these are different regulation, monitoring of metals and iodine in seaweed. Now, this is very peculiar thing. There is a iodine deficiency in India in northern part of the country, where salt is iodized. Yeah. Whereas in southern part, there is no iodine deficiency. Now, iodine is a big problem in this seaweed when it is fed to animals or humans, because they get huge amount of iodine. Whereas if this seaweed is introduced into a human diet in the country where are not having vegetarian diet and they do not consume seafood, that can be best source of iodine. This is the place where I went wrong. I said, wow, this contains an iodine. We can extract iodine from here rather than using chemical iodine. But this is a regulation that it should not contain much of iodine. Yeah, it's a problem at one place and solution for other. What disease do we get if we do not have enough of iodine? Very good. And that's thyroxine. Yeah. So that is one thing to do, metal one, because this also traps all the minerals and heavy metal from the water. So you have to watch out what are the metals and non-metals. And if you want to see the application of seaweed for food and feed application, there is one FAO document which was prepared 2 years ago, and that included people from all over the world from different countries. I was a part of this particular organization to prepare that particular document. It's freely available. Use of seaweed for food and non-food application or food safety aspect of it. It's a comprehensive document. It talks about the global level, not only for European perspective. Then you have maritime policy, framework, water directive, different regulations and novel food regulation. Yeah. And this is all related to Europe. Seaweed was used for cultivation for food purposes, then it doesn't come into novel food regulation. But if you are extracting an alginate or the species which is not consumed as a common food will come under novel food regulation. Same novel food regulation also regulates the use of technology for production of those ingredients. And this is all governed by European Commission, or EFSA is advisory body, European Food Safety Authority. What is the body in India? FASI. FASI. What is the full form? FSSAI. Sorry, this is wrongly written. Yeah. So they also have, FSSAI is also having a very comprehensive document. It says what should be the regulation and regulates each and every entity. Yeah. So that's the benchmark for any businesses done in the country. But if that ingredient produced in country has to go to the Europe, it has to comply with this regulation, or if it has to go to America, it has to comply with this regulation. Yeah. So each country regulations are different. I'll give you an example of egg. Eggs are kept in a refrigerator in US, whereas in Europe eggs are not kept in refrigerator, because egg washing is allowed in the US, egg washing is not allowed in the Europe. Yeah. If you wash egg, whatever salmonella is there on the surface, it will enter in. Yeah. Correct. So their regulations are different. So is the preservation strategy. In meat, you can use chemicals for preservation, whereas in Europe, only lactic acid and steam is allowed for preservation, or no chemical. Fish, no preservative is allowed for preservation. Yeah. And now the decisions are going to come in shortly, or maybe in a couple of years, to eliminate chlorine altogether. A. Second thing which might come shortly is the removal of all the Teflon coating. You know, all the non-stick coatings is going to be banned, because that contains fluorocarbons. So now alternative has to be there. How do you make it non-stick? Don't think about your pan for making food product. Think of the bigger baking ovens, bigger conveyor belt. How do we get alternative to this chemical? So there is always some problem to keep all the scientists in business. Yeah. So that's one. And the last regulation related to this is Habitat Directive, which is conservation of natural habitat, wild flora and fauna. Yeah. So that means, so these are the regulations all related to sea and all. They are not only these, there are multiple other regulations which has to be fulfilled. Yeah. Same thing, if you are want to use the sea to grow seaweed, then you need to have all those licenses. For small amount of harvesting for your experiment, even some experiments were done here in NIT Rourkela, where we just harvested from the beach. But if you are harvesting tons, then you may need a license or need a permission. Yeah. 1 kg of sand from the sea, you can bring it. But if you take a big damper or a big lorry, then it's a problem, right? The same thing applies over here. Any questions so far for macro? The only difference between macro and micro is what? Macro is done at a macro scale, micro is done at a micro scale. Is that correct? Yeah? No, it's not correct. Yeah. So just say it's not correct. Yeah. So any questions so far with macroalgae cultivation or duckweed cultivation? Good. So we'll ask a question, so each one of you will answer. Yeah. And I know who was saying no questions, so I'll ask them. Yeah. Now we'll go to microalgae cultivation. Yeah. Microalgae cultivation is as simple as what you have seen the duckweed cultivation. Yeah. So what you need again? CO2, light and water. It could be a wastewater, it could be a clean water. Yeah. And then you can get all this microalgae for range of different applications. Yeah. So that is input, no nutrients required. You can add in nutrient. You have conversion system, all the technologies to produce a biomass, and biomass for either for food application, fertilizer or a feed or biofuel. There could be much more description of this. Yeah. Now, this is too wordy. Yeah. And I'll be honest, this was these couple of slides were part of one of our own PhD who is producing microalgae from brewery wastewater. So we have a couple of PhDs and postdocs working on brewery wastewater to grow microalgae, to use fish processing wastewater to grow microalgae in combination along with a company which is based in Spain. Name is Neoalgae, ALGAE .es, yeah, Neoalgae, and all this thing is in impress-he.eu. Yeah, I already mentioned about this particular bigger project, and their octopus cooking water, well cooking water, or seafood processing water, we are using either to grow microalgae, macroalgae, or duckweed. Yeah. Now coming back to this one, nutraceuticals, which is very fancy topic. Some of you are doing PhD related to that. Pharmaceutical, which is obviously to get pharmaceutical drugs. Therapeutic protein and cosmeceuticals. Yeah. Therapeutic protein, that means they have lot of activity. Certain protein has shown effectivity against viruses, and these are again certain extract which are inhibitors of certain enzyme which are responsible for your weight management or for metabolism activities and all those things. So there are a lot of activities are ongoing at the moment for microalgal extract. Same thing, cosmeceuticals, moisturizer and all those hand creams. They do have lot of them. If you read through any of those expensive hand creams, if you read through, it will say seaweed extract or microalgae extract. Yeah, they do contain those in an ingredient form. You have antioxidants, skin whitening, fucoxanthin. Fucoxanthin is colored compound. Microalgal extract. Phycocyanin is a colored protein. Vitamin, minerals, and lot of carotenoids. And then you have different types of lipids. That all depends upon type of species. All seaweed will not contain everything, but depending upon the species. If you want to have, you all would have heard about spirulina, and you would have seen the cultivation of spirulina also. Water species, you collect it, you dry it, you have spirulina. It itself contains 60 to 70% protein, but still it will contain certain bioactives. You can prepare peptides and other application. Cholera vulgaris, cholera sorkina, then you have Purium perfidarium. A lot of different species are there. Each species, they have different requirement for growth. So that means depending upon your wastewater, you can select that particular species. Oops. So what are the first thing to do for cultivation of microalgae? You have to select different types of strains. Yeah, that depends upon what strain to select based on what is your target. Either to remove the nutrient from the wastewater, or your target is on a specific compound. So if you want to have to recover the nutrient from the wastewater, you need to pick a species which is having very high growth rate based on the pH and the composition of wastewater. That's one. Second is on the product. What type of product you want? You want a protein focus, lipid focus, or certain bioactive focus. Obviously, it does not need land for cultivation. You can do it in tubes, in circulating tubes, and you need a conducive environment. Same condition, whatever is required for growth of microorganisms, similar condition required for growth of duckweed. So, and all these things, when you get a strain, and there are multiple number of strains, whether it's genetically modified, naturally selected, or selected in somewhere. So one of the best ways, if you'll see some farm where the wastewater is going in and you see those species are growing, you pick those species and try to nurture and cultivate. Yeah, that's the way, could be the easier part. So what is overall process? One is open pond system, similar to aquaculture or duckweed. Photobioreactors. Photobioreactor looks a complicated word, but basically it's a reactor tube having a solution. You have something to purge air in it if it needs air. If a species needs CO2, you purge CO2 and needs light. Photoautotropic, heterotropic, mixotropic, photoheterotropic. That is again depending upon the species. You can, some of you know this word, I am not going to go each one of them. Based on that, what is requirement for them to grow. Second one is how do you harvest it. Simple harvesting is if you centrifuge it, cells will be at the bottom, yeah, A. B, you can have a coagulation of flocculation, that means separate the biomass. Centrifugation, if they float, you collect it from the top or you do the filtration, because these cells are something in microns, yeah. So, if you use microfiltration, you can get all those shells. Once you get those cells, that particular water can be reused or can be, is normally clarified, or BOD and COD is automatically reduced, yeah. That is it. And if you are focusing on extraction, either you mill it or use number of different technologies which we will cover in coming lectures. Different technologies can be used for extraction purposes, or you convert these biomasses by using the biochemical process, chemical processes or thermochemical processes. So, rest all extraction processing remains the same for whatever biomass you have, yeah. Cell disruption, that is breaking the cells to extract a lipid. Use supercritical fluid extraction to get the lipid. Use a solvent to extract a lipid, or you just get a lipid for whatever purpose, food purpose or for fuel purpose. It looks like such a clean slide. I am just making it dirty, yeah. So, there are number of different ways seaweeds are, microalgae is cultivated, yeah. Race away, that means how the water is moving, their baffles, you know, all these designs are based on to improve the efficacy. You may come up with much better design. Open pond, which is like a wastewater treatment system, or you have unstirred pond, stirred pond, you have plate reactor, you have column reactor. Column reactor, that means you have a funnel, measuring cylinder, that is also column reactor, yeah. But when you call it a column reactor, looks fancier. If you say, oh, I did it in a beaker, yeah. So, that is all, do not worry about these terminologies. And if you have a light around it, you have photo bioreactor. Bio, because you have biological origin substance in it, yeah. Technically, it is a simple column. Or annular column, that means again if you have some of the beads into it, there are a lot of systems are available commercially. If you browse through microalgae cultivation system, you can see hundreds of companies, hundreds of reactor. Technically, majority of them are just the configuration of different tubing system. Even if you will see the tubular reactor, yeah. So, the reactor, what sometimes I have seen is like a heat exchanger, yeah. Your heat exchanger and water is, I could have made a better one, yeah. And then you have a water going through this, and you have microalgae growing in here, yeah, and the water is pumped back here with the new water going in, and you have a filtration system here to collect all the biomass, yeah. And then you can have a batch type water going in. So, you can make it in this building all around with the tubing, and that is the way cultivation can be carried out. Something like hydroponics or aquaponics system as well, yeah. Similar type of arrangement can also be done for duckweed. Now, here all these designs depends upon your size, your intention and your timing and your purpose. If you are growing it for a very specific drugs or pharmaceutical bioactive or a protein, then if you are using your normal water for food purpose or for feed purpose. If you are using a wastewater, then purpose is completely different to produce a biomass, yeah. Now, these are some of the advantages and disadvantages of harvesting method. Sedimentation, cells left to settle on its own, because when they grow big, they settle at the bottom. Low capital, do not damage cells, does not require chemicals. And then disadvantages. Sedimentation. Sedimentation compared to centrifugation. You do in a chemistry, what is the difference between when you centrifuge it or when you leave it on its own to settle? Mix a sand and a water, you leave it for an hour, it will settle at the bottom, right? You centrifuge it, you get it in 2 minutes. So what will be the advantage of both the method? Same thing is here. Yeah? Centrifugal force, fast, this is slow. Yeah? So there is no difference between normal centrifugation, sedimentation compared to this one. Yeah? All species chemical free and all this. Coagulation, flocculation, same as wastewater treatment, how you create a flocculant. That means you aggregate all the cells together to make a bigger flock and remove it. Easy, fast, no contamination, it's physical method. Or contamination, large amount of area can cause cell death. Now, if the cell is only for recovery, not for further cultivation, you can use this particular method, flotation or filtration. Yeah. So these are different types of harvesting method. I haven't gone into the details of it, but it's water, you have cells in it, and how you separate those cells from the water. Yeah. In lab, when you are proving the point, what is your microalgae and what for it can be grown, what all it contains, you will restrict yourself only with centrifuge, because every lab contains a centrifuge. When you go for scale up operations, then you have to think of a better way of doing it, or to use 3-phase centrifugal pumps, which is also used to separate milk, cream and of different fat. Like dairy, we use centrifugation pump. Same type of things can be used for this purpose as well.
Sir, you have told that duckweed can absorb cadmium, lead and arsenic. So if we are using that duckweed to absorb those heavy metals, then what are we going to do with that duckweed? We cannot use that as animal feed or a consumption. Again, it is going to be a matter can either be created or destroyed. Again, there are going to be a heavy metal contamination.
Correct. So any of the product, wherever any operations are carried out, there will be heavy metal contamination is there in every food product. Yeah. That has to be regulated with this, regulated based on how much we can consume. Yeah. Now the question here is, if you see duckweed, microalgae and all, if your purpose of that water goes into the sea, all those heavy metal, whatever is there in the water can be absorbed by the plant. If same element, same water goes into the sea, same water minerals will be absorbed by the fish. Yeah. So that's why we also use these type of biomasses, not only your duckweed, even seaweed or even microalgae can absorb those heavy metals. That's why we also use them as phyto remediation. Yeah. That means how we can remove the heavy metal from the soil. Is there any other technique to remove heavy metal from the soil or from water? Yeah.
Sir, like in wastewater treatment, we can use activated carbon filters. That will be quick.
Yeah. Activated carbon, again, the whole purpose here is whatever heavy metal is accumulated into duckweed, yeah, and then if duckweed is used as a feed purpose, and then if you are extracting the protein, that extracted protein may not have that heavy metal. So everything has to be checked based on regulation. Yeah. Even if you are using activated carbon, yeah, if activated carbon is collecting heavy metal, after some time that activated carbon is saturated with heavy metal, then what we are going to do with that? Yeah. You understand my point here? Yeah. It is very similar principle applies how we can remove from the water. One is a reverse osmosis, remove all the minerals or so. There are multiple techniques are there. If your water is having heavy metal in it, that means that water used is coming in from the processing plant. That means your biomass itself, but suppose you have a dairy plant, yeah, any heavy metal coming into the wastewater, that means it is coming from milk, right? So if this does not contain, then this duckweed will not have that heavy metal.
But in case of seafood, sir, there is a higher possibility of heavy metal contaminants
Yeah.
from the sea source.
Yes.
In case of dairy, we don't need to check for the heavy metal contamination. The chances are very low. But in case of seafoods, the chances are very high actually.
True, because seafood is actually, we discussed the word called biomagnification, yeah? You know, all the fuels and everything leaking into the sea, you have all the metal contamination consumed by fish, yeah? And then fish is consumed by humans. So that's why all those, you would have seen a lot of news report, the seafood from A, B and C country was banned because it contains huge amount of dioxins or huge amount of heavy metals, yeah, correct? So that's, these are still the challenges which need to be addressed, and duckweed or microalgae or seaweed are one of the way of removing those heavy metals from the water, because the time will come when the sea is full of heavy metals if you are using for transportation purposes. Same problem is also with iodine. Huge amount of iodine is there, but if you are using seaweed for animal feed, and then the dairy product contains large amount of iodine. So this is the problem. Not only we are only talking about heavy metals here, but what about antibiotics as well? Yeah. So that's why we need to have all those solutions and possibilities what to grow which can recover those heavy metals. There could be other way to concentrate the nutrients. If you have silver in a water and a duckweed is absorbing a seaweed, then you get your silver harvesting, yeah, you know. So that's could be on other way around, and that's very, very valid question, and you think and come up with the solution how we remove the heavy metal from there. And if that heavy metal, if you do see the ash, you know, total ashing, how it is done. And then if that particular one, if you are extracting a protein in water, whether that particular heavy metal is attached to a fiber or it is attached to a protein. They are not freely available. They are bound in some form or the other. So there could be a way of removing those. Yeah. If you consume a whole biomass, A. B. If fresh duckweed contains 1 milligram per kg of cadmium, for example, which contains 90% moisture. If I dry it, this will increase, yeah. But you are not going to consume one full dried powder of a protein. So that's why regulations are set based on the proprietary product. Spices may have high level of heavy metals or or even salt will contain, like rock salt and all, which is coming from the sea salt or other one. They may contain all those heavy metals, but amount of salt consumed is minuscule quantity. So all those regulations are based on heavy metal per day per kg body weight. Yeah. So it fits in the regulation because body can also digest that. Even we get a lot of heavy metals in our body. You know, suppose working in a fuel, if you're walking in the water, a lot of metals are absorbed through your body. Yeah. Most of the waterborne diseases are not because of drinking water, but also working in dirty water. We would have seen that how the tapeworm enters into human body. So all those things are there, and it's very valid question. So whenever we do any process or any processing, we know what is going in and what is coming out. Yeah. Any other question?
Is there any toxicity studies carried out for duckweed and microalgae from the biomass production?
Yes, there are plenty of cytotoxicity. Cytotoxicity, that means how much of this particular extract is required for any given function. If they have antimicrobial properties, cytotoxicity is done, toxic against the cell. All the anti-cancerous activity, yeah. If you have this as a cell, yeah. The moment you add the extract, yeah, this cell divides into two. So will it be cytotoxicity? It multiplies the cell, yeah. So it is not having anti-cancerous property, then this is considered as your wound healing property if it is multiplying the cell, because cancer is uncontrolled growth of cells, yeah. So if it is breaking the cells, it becomes cancerous property. So all the cytotoxicity, that is what is the minimum concentration required to get antimicrobial effect and how much it will affect the human cells. So any of the ingredient proposed either for human application, pharmaceuticals or nutraceuticals, cytotoxicity is must, yeah. And all the cytotoxicity on a specific ingredient, whether it's astaxanthin from seafood side stream, carotenoids, Purium perfidarium or Cholera vulgaris, all these extracts are done. And cytotoxicity is not only because the extracted ingredient, but also by the technique you have extracted. So that is nowadays a must if you're going for any of those application, yeah. You suppose take phycocyanin. Phycocyanin, that is color bearing compound. This orange color, purple color or green, all those things are some are the phycocyanin, some are chlorophyll. So phycocyanin, if this is extracted by using microwave or ultrasonics or by plasma, it may have certain oxidation into it, yeah. So this is not because of phycocyanin, but because of extraction technology. So cytotoxicity and their functional and biological properties are carried out once you are trying to prove the application of it, yeah. So even that's very important for any of the ingredient, otherwise there is no point in producing an ingredient which cannot be used for application. And literature is full of those cytotoxicity, and if you want, we can go through with all those things, but it becomes slightly complicated. The reason I was saying here about anti-cancerous activity or wound healing, that's the basic test done to say if you put an extract, what is the dose required to break the cells, whether take for example 1 milligram per ml of solution is sufficient enough to cause antimicrobial activity, yeah. And then you do the cytotoxicity, and what is the concentration will cause cytotoxicity. That means if 2 milligram per liter is the limit for cytotoxicity, then this can be used for as an antimicrobial activity or antibacterial in food purposes. But if cytotoxicity is 0.5, then this is not the suitable one, yeah. So cytotoxicity is a must must be done in order to show the product application, yeah. Any other?
Sir, what about the heat sensitivity of the duckweeds and microalgae, sir? Because you ask only the non-thermal processing for extraction of microalgae. What about the thermal treatment? Like the cultivation process and growing process is very easy and conventional method.
Yeah.
If I want to grow the microalgae in our pond, another thing, I go to the expensive method to extract that microalgae. So what about the heat sensitivity of that?
Okay. Now heat sensitivity depends again on the ingredients, yeah. If if you see duckweed, for example, rubisco is very temperature sensitive, yeah. And certain ingredients, when we are using the high temperature, they will lose their bioactivity. For certain ingredients are only extracted at higher temperature. Carrageenan, for example, you cannot extract it at the cold temperature. When we are saying non-thermal technology, there is a difference. We can classify it as a novel technologies, yeah. For extraction, what is the most important principle? If you have a biomass and there is something trapped inside, in order to extract it, what you do? You add it into a solvent, yeah. What is required? Solvent slowly goes into it, solubilize the target compound, comes into the suspension, yeah. You centrifuge it, residue is out, what you will see when you go back to the lab, yeah. And this is the extract. Now you have to collect it from this extract. When you use ultrasonic, for example, what it helps in allowing the solvent to get into the biomass. Yeah, it is not only for the temperature side of it, but also to improve the diffusion. If you have dry powder, before you extract, first thing is powder should be hydrated. Yeah, if you cook chickpea or anything, what you do? You put in hot water to soak it. What will happen? Outer surface absorbs the water, it doesn't penetrate in. Majority of the process, what is there? Overnight soaking, because slowly it penetrates into it. Yeah. Same way, if you put the same water in a microwave, the soaking same amount of water is absorbed in 10 minutes. Yeah. So the microwave assisted. So what you can achieve in 16 hours, you can achieve it in 10 minutes. That the purpose of the technology is where you want to heat or non-heat is second question. Yeah. One is you use a technology based on what is your objective there. Yeah. If suppose you are talking about heat, but certain antioxidant or bioactive compound, they are antioxidant, that means they can oxidize easily. If you are doing 16 hours of extraction, you are also adding lot of air into it. Yeah. So property is already gone or reduced to a certain extent. If you use ultrasonic or microwave, even though there is a thermal degradation, the thermal degradation is suppose 2%, yeah, but you preserve its oxidation properties. Yeah. So that is the balance what you have to do. Think of your thermal processing. If you can achieve 5 log, yeah, this is the curve for 90 degrees Celsius. Yeah. This is your inactivation curve for 70 degrees Celsius, and this is your curve for 110 degrees Celsius. Yeah. To achieve this much reduction, you get at 3 times. Yeah. A, B and C. Take it as 2 minutes, 5 minutes and 10 minutes. Which one you will pick?
2 minutes.
2 minutes, right? At 110 degrees. Why? It's shorter time. But this 100 and now it becomes a complicated one. This is take what product? Take it as juice. Yeah. Now you do the ascorbic acid kinetics. Yeah. And 2 minutes at 100 and okay. Ascorbic acid 110 is like this, 70 degrees is like this, and 90 degrees like this. So that means 90% of ascorbic acid is gone in 2 minutes, whereas when doing for 10 minutes, only 15% is gone. So selection of the condition depends upon what are the other things. If you read Louis Pasteur, the first book, I can make a product which is safe for consumption for 25 years, but there is no nutrients left in it. Yeah. So there is a compromise between economy and nutritional properties. Yeah. So that's the way when you select a process. So multiple unit operations are there. If you see milk powder, how many of you have made a tea out of milk powder? If you add a milk powder in a boiling water, what happens? Does it dissolve? For dissolving milk powder, you need lukewarm water. 40 to 42 degrees Celsius is the best way it formulates. Yeah. Now this is the biggest problem with infant milk formula, because this is also a temperature very best for microorganisms to grow. Yeah. Right. So in Chronobacter sakazaki, it is not there the moment milk is formulated, this bacteria gets activated. Yeah. Food safety people want you to have it at 72 degrees Celsius. But to have a better solubility, powder properties, to have flowability and nutritional and everything, you need lower temperature. Yeah. So what is the best solution for that? Which one you will pick? 72 degree, you can't make a tea out of milk powder. Yeah. So that's why you have to think. So what is the best solution for that? You can get rid of microorganisms also, and you can have a best mixing. You start boiling the kettle. This is what I do all the time when I have to make tea here. Yeah. and take whenever lukewarm water, a small quantity, make a milk, yeah. When water is boiled, then add to it, yeah. So the temperature overall itself will be 82. Once it is solubilized, the powder is hydrated, then you can increase the temperature and you will have the perfect milk. So same thing applies for extraction. Half the time when we say conventional extraction takes 16 hours compared to ultrasound 10 minutes, because in conventional method first 5 to 6 hours only goes in hydration of the powder. So there again, freeze dried powder hydrates faster, hot air dried takes longer. If drying is done at 40 degrees Celsius, lesser nutrients are lost. When you dry it at 100 degrees Celsius, which takes less time, half nutrients are gone and it becomes harder, yeah. So it's like a mess like this, yeah, okay. So all these things you have to consider before drawing the process. So one is unit operation, yeah, and one is to make a process. Raw material, washing, drying, extraction, yeah, spray drying to make a powder, yeah. Raw material like orange, you wash it, remove the moisture, peeling, and you just extract the juicer, then you spray dry it, you get a juice powder, yeah, right. But if the moment you open an orange, you get whole room smells like an orange. But if you open orange powder, you don't get that smell. So all those volatile gone in different stages, yeah. So when you make a process, you have to consider all those unit operations, then only it can be integrated into a different steps. As your colleague was asking the question about cytotoxicity, any product used in a food application or hand cream, cytotoxicity becomes the most important one before you prove its point. Yes, it can kill all the bacteria, but it can also kill a human being also, yeah. Okay, I'll just draw one experiment here, you draw the conclusion, right. There was a school kid, yeah. Teacher kept 3 beakers. In one there was alcohol, yeah. In one it was smoke. You can take it a cigarette smoke or any smoke. In third one it was a clean air. One insect was added to each of these jars, yeah. Insect in this died, insect in smoke died, insect in this survived. So what is the conclusion of the experiment? Anyone want to conclude this experiment? Come on, this is a very simple experiment. Everybody said alcohol kills insect, smoke kills insect, clean air is good. But one little Johnny, he concluded, as long as you are drinking and smoking, there won't be any insects in your stomach, yeah. So drawing the conclusion of the experiment should be done based on logic. You can draw any conclusion, yeah. A lot of such stories are there in science where we do experiment and we draw wrong conclusions, yeah. So that's why it is very important when we arrive to the conclusion, suggesting anything, to you weigh all the aspect of it, then only you propose, yeah. Because what looks straightforward may not be easier. There's another experiment related to a cockroach. Dissection was going on, somebody cut one leg, asked cockroach to walk, cockroach crawls. Then he cuts another leg, asks cockroach to walk, starts walking. Like that he cuts all 6 legs and cockroach couldn't walk. What was the conclusion? After losing all 6 legs, cockroach became deaf. That could be a conclusion, right? But insect could not walk because of leg. But the conclusion was written, after losing all 6 legs, cockroach became deaf. That means he was no longer taking instructions, yeah. And you'll see number of different features, because whatever experiment you are doing, I will ask you all the aspects. Some I have already covered. Some will ask the question when you finish off your experiment. So with this, we conclude today's one, and you are going to go to the lab to see your experiments, yeah?